Okay, here. Morning, guys.
Hi,
How are you?
good.
I'm glad to hear it. Does anybody, while we're having people join in the Pear Deck, does anybody, Pear Deck is PXYWHY. Does anybody have questions about their locker things for next week?
What do you mean locker things?
Did you not see the tech task today about, and were you here yesterday? You must not have been. All your things will be gathered out of your locker and there's a pickup next week. I'll go over it again in a second. Anybody have a question that was in the Zoom yesterday? And then I'll get in.
I do.
Okay.
Can you bring Winston outside with my locker stuff?
Yep.
Yay.
That's the kind of stuff that I want to make sure that is clear. Yes. For
Okay,
sure.
thank you.
And if somebody's wanting to babysit some other critter for the summer and you want me to bring it, you just bring it back.
Me.
So just put that in the tech task. Of course.
I already finished the
Winston-
tech task.
Okay. Well,
Can
then
I just send you a text or something?
yes.
Okay.
Now, the ones that belong to the classroom, you have to bring back in August, of course. But like Winston belongs to Mellis. But yeah, you're welcome to. Like Lincoln Jr.'s been with Lincoln since March. All right.
Wait, but
So here's the deal. On the tech task today, it's asking you questions about, are there things in your locker that you want me just to recycle or get rid of? Or do you want them packed up in the bag? It'll be a trash bag that I'll put your stuff in. Same thing for your desk. If you're not sure, like let's say I know there's this and this I don't want. You can say that. If you're not sure about other things, that's okay. I can also, when I'm there on Monday, I can take a picture and text it to you individually, and you can say yes or no if you want me to. If you have a lock on your locker, like Dr. Underwood was at the Graymar building, he said there's only like 2 or 3 locks in the whole upstairs. So if that happened to be one of yours, like I think I remember somebody having a lock on theirs. So if you want your lock saved, you just got to send me the combination to get into it. Otherwise, they'll cut it off.
Most of our
So then Monday, this coming up Monday, the teachers will be there on Monday or Tuesday in staggered shifts. We have to go a few at a time, and we will pack up what's in your locker. And for my class, it'll also be what's in your desk in the room because of being self-contained. You all have stuff in your desks. So that stuff will be gathered in a plastic bag, like a trash bag. And then your name will be put on it. And then on next Thursday, a week from tomorrow, you all have a time to come by the school. Dr. Underwood sent directions out on an email to your parents. So I think 6th graders come next Thursday, the 21st, from 1 to 5. You drive up. There'll be tables in the parking lot. And those tables will be like, I have library books. I put them here. I give them to that person. If you have medicines in the office, Ms. Osborne will be at a stand and she'll give you that back. Band instruments, strings instruments. If you have textbooks, there'll be a person to pick those up that you happened to take home on that Wednesday that we were at school the last time. But that'll be next Thursday. But again, anything you need special directions about, put them on the tech task. If you've already finished it, you can just send me an additional text and say, put that in because I'm making a spreadsheet with every kid's name and directions of what I need to do for you. And if I need to send you a picture from my phone when I'm at school on Monday, the thing is you'll need to be watching and waiting for it because I'll have to move quickly. But I'll give you more about that by Friday or. Hey, Kimani, turn off your microphone, please. Okay, please mute yourself if you're not muted. That's not a hard direction to follow. All right. So that's the deal on that. Any questions about the pickup? Any questions? All right. So as I said, today we're going to start talking about graphs. So let me go ahead and start. Okay, I only have 5 people on the Pear Deck. I need you to join the Pear Deck, please, if you haven't already. PXWHY. All right, so first thing, here is a slide. Will you please, on the slide, type or write out with drawing tools what kind of graphs you know about and what would be their purpose? Any graph that you know about and its purpose. If you don't know, or you can be a guess. Also, Josiah, will you turn on your microphone so I can ask you a question? All right, I'll give you about 15 more seconds. All right, so I'm going to go through and see what we got for responses. So this person is talking about their histograms and pie charts. Here we've got histogram, pictograph, scatter plot, line graph, bar graph, pie chart on this person. So showing those two, which is a pie chart, and that other one is a scatter plot, bar graph. And you can have one on a line, on a bar, using percentages. We're going to talk about that. Same thing. All right. So let's go ahead and talk about these 5 kinds of graphs that we're going to talk about over the next couple of days. All right. So there are bar graphs if you want to jot down some notes. So no, first of all, let me ask you this question. So you've got, that's on the next one. Okay. This is a drag the icon. All right. So drag your dot right now beside the graph type that is just about giving data. So put your dot beside the one you think its job is just straight up give you data. Okay, yep, that's a bar graph. All right. Which kind of graph is the graph where you take like bar graph data and you give a percent of the whole amount of people in the graph? Okay, that's a circle graph or pie chart. Same thing, circle graph, pie chart. All right. Which graph is the graph that you show change of graph data over time? So the time is going to be your one axis, your X, and the number is going to be your Y axis. And that's a line graph. And notice I said that that's always a line graph is about change over time. And remember that the X axis is the axis that determines the Y. And would it not make sense that the time would determine the number? So the time would have to be the X axis because the day of the week or the time of the day or the month would let you know what the number is on the Y, the dependent variable. Okay, so yeah. All right, so let's move to the next one. All right, so let's talk about a little bit of a definition. So a bar graph, the definition of a bar graph would be to simply compare data with specific things like favorite ice cream flavor, strawberry, chocolate, vanilla, Rocky Road, cookies and cream. And then you just get people's answers and you compare the number. That could also be a scatter plot. Circle graphs, you take that same data and you count up how many people were in the entire survey. And then you get the proportion of each answer to the total. For example, if I did a bar graph and I did our class's favorite color, there are 25 people in the class, right? And I said red and I had 7 people. And I had blue and I had also 7 people. And then I had green with 2 people. And then I had, what's another color I didn't say? Purple, and that was everybody else, okay? So a circle graph, I'd take those literal numbers and I would see what that percent of all of it is. For example, when I said that red was 7, that would be 7/25. And then 7/25 as a fraction would be 28%. Because that'd be 7 times 4 is 28, right? So then I would make a circle graph that shows 28% for whatever color I just said, and then the others would be another slice of the pie. A line graph is a totally different thing. A line graph is when you're talking about adding the change of the numbers over time. For example, let's say that you were talking about the money you earned each day at your restaurant. And Monday, the restaurant earned $1,400. On Tuesday, the restaurant earned $1,322. On Wednesday, they earned $1,460. So you're literally putting those dots over those days. The thing is, it's tricky to think about a line graph because connecting the dots needs to make sure that the thing you're graphing can have in between amounts, right? And we'll talk more about that when we talk about line graphs. It could just be that you put a dot there, but you don't connect them. People connect the line graph dots just to show the trend, if it's going up or down, right? And then histograms are about assigning intervals. For example, what if I were wanting to show a graph that showed how many people made an A, a B, a C, a D, or an F on a test? Something like that could be a histogram. But there's a key there. It's got to have intervals that are the same. You can't have one interval that has 7 points in it and another one that has 6 points and another one that has 7, another one that has 8. They have to all have the same number of the range, but we'll talk about that tomorrow. And then box and whisker plots. Yes.
So what's the definition of a histogram?
Histogram is about tracking data in intervals. So I'm looking at the intervals, like most of the data is in the A category. The least amount of data is in the D category, of a group. Does that make sense? But the thing is, I could not do literal A, B, C, D, and F. Here's why. The range of A's and B's and C's and D's and F's are not the same. So that would not actually be a true histogram. I could do a histogram that says how many people made a 90, how many people made in the 80s, how many people made in the 70s, how many people made in the 60s, 50s, 40s, because there would be the same number of intervals there, right? So 90 to 99, 80 to 89, 70 to 79. So that would be a true histogram. And then a box and whisker plot, and we'll talk about each one in more detail over the next couple of days. A box and whisker plot is literally when you're looking at like TCAP or you're looking at map testing, where they say, oh, you're in the fourth quartile, you're in the first quartile. And that kind of relates to below basic, basic, proficient, and advanced. Those are literally quartiles. Quartile means a quarter of the data. So you actually, on a box and whisker plot, you get all the data, you put it in order, you find the median, and the median is the divider between the first and second quartile, third and fourth quartile. Then you divide the first half, that becomes your first and second, and you divide the top half, and that's your third and fourth. So could you have a lot more people in one quartile or the other? No, you divide it by equal amounts. Can the quartiles be different lengths? Yes, but we'll talk about that, all right? So that's an overview. All right, up next. So let's talk about bar graphs. All right, so on this screen, tell me the things about this bar graph that are important to know. Right on this screen, what's important to know about this bar graph?
Would it be the y-axis?
No,
Sure.
write it on the screen,
Oh,
please. Also, while you're writing that, could someone send a photo to Josiah of the password reset email address? Remember, I sent out a picture. Does anybody have that saved? Because he needs to have his password changed. And if you have it handy, because I'm going to have to dig for it, that would be helpful. You remember I sent that picture because it's your first name, capital letter, your last name, lowercase letter. Then it's 2 digits, 2 digits, 2 digits, but there's an email you got to email that to. If somebody has that picture and could post it on Parsons 17, that would be great after we're finished. All right, Jayla, will you talk about what you have on your screen?
So I circled all the important things.
All right.
Like the
Go ahead.
title, you should want to know what information you're
All right.
getting.
You have to have a title so you know what the data is about. Okay, what else?
Like and how many of this stuff, like this number, like all
right
of those
here.
numbers right there.
So this is the number of each item. This is the y-axis, right?
And you need
Also, notice, what do you notice about the intervals of the numbers on the y-axis?
they're going up by 5.
Okay, do they have to go up by 5s? Jayla, do they have to go up by 5?
Yes, once you start it, like that, they have to continue going up by
Okay,
5.
if you start it that way, you want to stay that way. Can you count by ones? Can you count by tens? Can you count by sevens? Can you count by twos? Yeah, but you want to count by the same interval because otherwise you're going to make your data misleading. And we'll talk about misleading graphs.
And
What else?
you want to have the item, like they have the fruits.
Right here.
Hmm.
And that's your x-axis, right?
Yes.
Here's
And-
why it's not the other way around. The fruit determines the number, right?
Mhm.
So you got to know, I'm talking about apples. Okay, well then I've got 35. You're talking about blueberries, I've got 40. Grapes, I've got about 5, etc. Okay, what else?
And you want to have the data, of course, because that's what you're
Obviously.
measuring out.
Data
With.
as well.
And you need to have like the data to get the total number of participants.
Yes. All right, correct. Okay, Permita, tell me some things that Jayla didn't say that are also included on yours there, please.
So basically mine is the same as Jayla's with just a different way of saying the stuff. But I have the blueberries the most liked and the grape is the least liked on there.
So you added a couple new things that are also things you noticed, that
Yeah.
you looked at what's the largest and what's the smallest numbers that people, we don't know, we assume this is people's votes. They say, what's the nicest fruit? And everybody voted. How would we go about making this a circle graph? We would need to know what. Let me ask somebody who hasn't talked. Let me go through here. Liam, what is something that we would need to know that we don't know right now without doing a little bit of work to make it a circle graph? Well, first of all, we know the blueberry would have the biggest slice of the pie, circle, and that the grapes would have the skinniest slice. What's the one thing we need to also have that we don't have right now?
The total.
Yep. We would need to actually count up the total number of votes, right? So we would need to add 35 plus 30 plus 10 plus 25 plus 40 plus 5. And then that number, we would make a fraction and we would say, oh, so Apple would be 35, say it's 200s. I don't know what it is, whatever that number is. It's not 200. But you would do that and then you would turn it into a decimal, right? And then, or a percent, which would then become a percent. So if you turn that into a decimal, then you make it a percent, then you know how big the slice is for that thing. Making a circle graph would be the hardest graph to make. You think, oh, it's simple. No, it's harder because you have to convert the fraction to a decimal to a percent, and then you have to know how to do degrees of 360 degrees in a circle and get that as a percent. So it's just more work to the math. All right, let me look and see if anybody said anything drastically different. I think we're about all this. I know here, let's see. Let me get Betty's on the screen. Okay, Betty. Did you say anything else that you'd like to add?
Yeah. Well,
Yeah.
the 5 doesn't mark its
Yep.
position.
Right here. So that 5, I was wondering if anybody was going to catch that. There's an error because this mark is missing right here, right? So you need a mark here by the 5 to make that clear. All right, so let's go to the next graph. All right, tell me one takeaway from this graph. On your slide, tell me one thing that you take away from looking at this graph. It could be a correct thing, it could be an error. I'm not guaranteeing that there's not going to be errors stuck in here. I've put some purposeful errors in the graphs. Not on all of them, but a few here and there on purpose. All right, I'm going to turn on the responses and let's just go down the list and see some things that have been said. I got to get this out of the way. The least amount of people like movies that are dramas, according to this. Okay. This person said that romance movies are liked by people for some strange reason. That's funny. 20 people in total. Romance is the most, drama is the least. So this person says 20 people in total. Now, with that being said, I could make a pie chart because I would have my fractions to create my percents. That's correct. The title is inside the graph, which probably should be at the top. I think it'd be better if it were at the top. Okay. So this person says times 2. So they just marked every other interval mark with the number, but obviously the ones in between are the odd numbers, which is that okay? Yep. It says all of 5 are on an even line. So everything had an even response. There were no odd numbers, just coincidentally. Same number of people like sci-fi and comedy. That's 4 total. So yeah, here's another one. Again, tell me something you notice about this graph. And again, all of these are bar graphs and all of these could be turned into circle graphs. Would any of these have any reason to be a line graph? The answer is no. None of these would be a line graph. That would make no sense because we're not talking about, well, my favorite pet this month is here. My favorite pet next month is this, because we're talking about one set of data at one time. And line graphs are going to be talking about how the data changes over a period of time. All right, so let's see what a couple of people said we're gonna do. We'll do one more graph right after this. So 34 people total here. The most would be cats. The least would be rabbits. This person said, again, cats the most. I wonder who wrote that. Any guess?
No,
Nah, it's complete. It's such.
No
I'm
doubt who did that. Okay.
so difficult to figure it out.
No doubt that was Melis. This person says that the more people should own hamsters, but that's not saying that's the least one. This person was just noting that that was lower than maybe they anticipated. That's the whole point of a graph, that you can see the numbers visually and it can help you to know more about the list of data. Are these all questions that are statistical questions that make graphs? Of course they are. Here, the numbers go up one by one on the y-axis. This person made note that you don't see the lines. Do you have to have the lines? You don't have to. I think this person is probably thinking the lines being there are better, but you don't have to have it. They also made some notice about cats being the most, which they didn't necessarily agree with. And then this person also found that rabbits least, cats most, 34 people. So we know that 4/34 of the survey participants have rabbits. We know that 11/34 of the people have cats, which is basically a third. So that would be a third of a circle graph when you did the math. This person also noticed the leader of the cat being picked. This person says, we don't know the total participant number, But they counted them and they realized 34. And they also gave us the range that from the most popular to the least popular is a 7. Would you consider that an outlier for cats? Nope, you wouldn't, because you've got an 8, you've got a 6, that wouldn't be an outlier though. It just had more participants. Okay, last question or last graph for today. All right, now this graph is different. Will you tell me on the screen what's different about this graph than the graphs we've done earlier today? That again will be the last question for today. What are the things that make this graph different besides the topic? What are the characteristics of the graph that are different from the other graphs? All right, so I'm going to share a couple of responses. This person said it looks like our TCAP scores. Could this person tell me what about it looks like your TCAP scores? Jayla.
So on our TCAP scores, I meant MAP scores. Well,
Sure.
both, because
Yeah.
they show us like by the years or months.
Yep, because when
That's
you
how
get
that
your
works.
MAP score, it shows you the previous couple of MAP tests to see how they've changed, right? Yep, that's right. So multiple responses for each of the same things. Let's go on down the list here. This bar graph has many bar graphs grouped together. All right, also correct. There's a graph inside a graph. Has more information and a key. So it also has a key and it shows more information. So it's actually showing you votes for 4 different fake superheroes by ages of kids at maybe it's a daycare or something. I don't know. But it's telling you how many 1-year-olds like Mighty Man versus Speedy Sally versus Tornado Terry versus 5-year-olds. Okay, so it's what we call a double bar graph. So you're actually quadruple. So you're getting 5 different ages and it's broken up by superhero, right? Whereas you could have that as 4 different bar graphs. You could have a Mighty Man bar graph for 1-year-olds. You could have a Super Sally bar graph for all of those 5 ages, etc. So it's actually taking multiple bar graphs and putting them together. All right, this person said we've got each of the superheroes by each of the ages, and they want to know who in the world these peeps are. I don't know. This person says that we've got multiple items on the x-axis, and we've got the 2, 4, 6, 8, 10 on the side, and we also are going to have a legend or a key when you do that. Because of the fact you've got multiple data. Again, many graphs within the same one. Again, that is a thing. It's called a double bar graph, and I would think you would know that from other years, but I just want to make sure. 4 choices. And so why would a person not just put these on separate bar graphs? Why would it be better to put them on one? Could somebody talk about that just really quickly?
I can.
Okay.
I can.
Okay, both of you do that.
Because they're talking about the same topic.
So they're asking the same question. Which of these are your favorite? And they're doing that with grade levels. I mean, age levels. Okay. The other person I think was Betty. Was it Betty?
Yes.
Okay.
So I think because like yes, as Jayla said, they were trying to like separate it, but also that I think there would be too many to fit in a graph, though they could have just like instead of like separated it by twos, they could separate it by like fives or something.
So they could make the intervals over here by fives instead of twos, or even by ones. Totally fine. Anybody else? So those are correct, but I still want to ask, why would this be better to look at than the separate graphs? Because I think it's better. What makes it better? What do you think makes it better to look at the data? Somebody else.
I think that with all of the data in one, you can sort of see what different ages think at different times in their lives, so you can compare them more easily.
Exactly. The whole point of a double bar graph, and in this particular case, is so you can make some comparisons by superhero and by age levels. So with that being said, I can make some obvious, I can make some trend analysis here. I couldn't think of the word I was trying to say, which I still can't think of. I'm noticing that Mighty Man is more popular generally with younger kids, and the older kids are a little more into what? Vanessa? Do you see that? You see that Mighty Man hit its peak at age 3 and then declined? So it rose and declined. You see that? Do you see that Tornado Terry is popular with 3-year-olds by far more? Do you notice any other trends like that? Looks like Sally was popular and then dipped and came back up, right? So you can just see trends. So a double bar graph can give you some information about ages that way. All right, so that's it for today. It's got to cut off. I will see you back over on the other Zoom for GimKit if you're interested. And 2 o'clock will be the 6th grade Zoom for GimKit.
Bye, guys.
All right. See you guys. All right, bye.
Bye.
See you later.